Hi and welcome back to a new episode of in the R course. Today's episode is about matrix. As we saw in previous videos talking about lists or vectors, there are more structures in R to deal with our data or to how to handle our data. In this case, matrix is a very important data object because, as we will see in the future, matrix and arrays are related. Okay, this is how we define a matrix. We input the information we want to, and also we have to tell R the dimensions of our matrix. Okay, let's see, for example, here, once we have defined this matrix, in this case I call it my math. As we can see, our object is here. We can see it is 1 column, 5 columns, and 10 observations or 10 rows. Where is that information? Right here. 10 is going to be the number of rows or observations we are working on, and 5 is the number of columns. Okay, that means that we have a matrix here of 10 by 5. 10 rows, 5 columns. Okay, this is one way to call the matrix we just have defined the dimensions. Okay, the structure of our data, as you can see here, this is like a vector, but as long as a vector with how many elements? 10 by 5, that means 50 elements. Okay, and also we can change this if we have to a data frame, just calling the function we already discussed is as data frame, my data, call it my data, and my data. What is the difference between defining the function as matrix and as data frame? Of course, it is how to handle it in different functions we can use for matrix and for data frame. Okay, also is the name of the each column. Again, it's important we can handle all this information in the data frame as columns. Also, each column could be represented as a list or a vector. Okay, let's see what is the structure behind. Okay, as we already saw. For example, here, I already wrote 30, 29, 19, 27, 23. Somebody could say, okay, this is your first row. Okay, but if we go and see what are just printed from me, it's totally different. 30, 21, 25, 20, and 29. None. Only the first observation matched. So what's happening here? If I have 10 different rows and 5 columns, why does R don't present my information as this? Okay, that has to be with how R will take the information, by row or by column. Okay, in this case, as you can see, R will, or R when, for the first column, and fill it like this. 5 plus 5, 10 observations belong to the first column. Okay, 30, 20, 19 to 21, as you can see here. So that means it was filling by column. What about if I change this and I say by row equal false? How the information will change, or is the same? Okay, and we will see my math. As you can see, the information is the same as we previously had. Okay, that means that the default statement here by row is false. Once I change it by true, the definition of my matrix will have some change. Okay, let's see now. It's identical as I wanted to. You see, 30, 29, 19, 27, 23. Okay, that means that it's important how you're going to define your matrix and how R will present it for you. Okay, here I didn't write anything, so R took the defined or the default option that is false. Okay, that means that it take it by column. It filled each column, and then the next column, and so on. Here, as you can see, what is going to be the result here? Let's guess. Really think about this. If I say by row, that means that it's going to take 3 columns, three different elements for our first row. That means that it's going to be 2, 4, and 3 for our first row, and then the next 3 observations for our second row. Okay, let's define A, and let's print it. Okay, as I thought, 2, 4, 3, 1, 5, 7. Okay, why? Because I told R that it's going to be by row, so it's going to fill the information or fill the matrix by rows. Okay, dimension 2 by 3. Okay, remember the default here is fill the matrix by columns. Okay, but we can change this with this data observation. Okay, and what about if I don't tell R what is my number of columns or number of rows? Let's see, X is gonna be 12 elements. Okay, X, okay, is a single column, 12 elements. Okay, that means that no columns or no rows, then we will have one single column, sorry. Okay, then I just change this, telling R what is going to be my number of rows or number of columns, but I desire. Okay, 3 times 4 is 12, so I don't have any problem here. Number, that's the dimensions, and row, and call. Is it a matrix? Look, that this function is important if you want to test if you want function or a data object, sorry, is a matrix or not. Okay, it's true. Also, as we saw in list, even in vectors, we can change the column's name. Okay, so I'm going to give 3 different names to the 3 different columns in my matrix. Okay, and also I'm going to give row names. Okay, call names, row names, and let's see what is X now. Okay, as you can see, there are names for each observation. For example, Pierre H is 1, Pierre Poix is 5, Quentin H is 3, and so on. Okay, I can identify the different H by H 1, 2, 3, and 4, 8, 9, 10, 11, 12. Okay. Here there are some functions we could use directly. For example, here using the function apply, we're going to calculate the mean. What is number 1? When we use apply, we're telling R to calculate for this group of data, X, in our case a matrix, it's going to calculate the mean by row. Okay. By row. Okay, for example here, Pierre is 1 plus 5 plus 9 is 15 divided by 3 is 5. Okay, the same for car, for example. 4 plus 8 plus 12 is 24 divided by 3, it's 8. Okay, that means that this one here is important. And all the same, if we wanted to by column, that means we're going to calculate the average for H, the average for point, the average for odd. Okay. Okay, as you can see here, H point odd. And here the sum for all of them. Okay, and even here we can calculate, or we can print the information for Frank, for example, for H2. Remember that the commas are important. Okay, comma here because we're talking about a row, and comma here to the left because we're talking about a column. Okay, this is matrix, and what we can do with matrix and how we define a matrix. Okay, let's move forward. How to identify or how to select a different element in a matrix. Here I'm selling R, that's second row and third column. Okay, 7. Remember what is the word matrix? Okay. Here what we're telling R, okay, as I mentioned before, second row and no columns, that means all the columns. 177, 157. Here, third column, no row, that means all the columns. As the same as we work here with given names. And here, what we're saying here, okay, I want the first column and third column. Okay, we are selecting different columns and print them. Okay, it's important. The next operations are really important. Is what can we do with matrices in R? Okay, is it possible that a squared is the same than a times a? Okay, we're gonna compare this. Let's define P as a matrix of 2 rows and 3 columns. Let's see B, is this? Different operations we can work here is A plus B. Remember that there are some rules for adding matrices. Okay, A is also a 2 by 3 matrix, so we can add with no problem. And as you can see, B plus A is going to be the same. Okay, it's the same result. No different here. The same for the subtraction, but of course it's important here the order. Okay, multiplication, A times B with the asterisk. You can see here an asterisk, the star. Okay, is it the same multiplication here? A times B as we know in linear algebra? Okay, let's see. Okay, remember, if we have a matrix 2 times 3 multiplied by another matrix 2 times 3, it's impossible to calculate under the normal rules of multiplication. This is not possible. Not possible. Okay. If we are under the normal rules of multiplication, this is not possible. So what is R doing here? Let's compare A and B. Here we have A and we have B here. And let's compare the result. So you can see here is 4. That means it's 2 times 2, 3 times 4 equals 12. That means that this operation is element multiplied or times element. Okay, element A in times element B. Okay, that means that this is not the normal multiplication. So how do we do this? Okay, before doing this, we will see, or I'm going to show you that this is element times element. This is possible because we have a 2 by 3 matrix multiplied by a 2 by 3 matrix 2. But C, for example, is the opposite. 3 rows, 2 columns, and we will see here. And we want to multiply element by element. This is not possible. Not conformable arrays, as I explained why. So how we are going to have the normal multiplication is using percentage. Let's see. Oh yes, this is possible. This is the multiplication. Multiplication of matrices. Okay, And what about B times A now under this operation? Ooh, not possible, right? Because it's not, in this case, it's not possible, as I explained here, under the normal multiplication. Okay. Let's see the result of C times A with that normal multiplication. We store this in D, and we use that for calculate the determinant of the matrix D. Okay, as you can see, this one is going to be a singular matrix. Let's use this example. Okay, here we could say, okay, that's the transpose. Okay, let's see what it does. C to T. Okay, and now what was C? Okay, does it change? Not at all. It didn't change at all. Okay. Okay, let's see A to T. What it? If we compare, it does not. It did nothing. Okay, that means that this is not transpose. The transpose is using this function here, T, and inside the parenthesis the matrix we want to calculate, or for the one we want to calculate the transpose. And here it is. C is a matrix of 3 by 2, and then when we apply transpose, we obtain the transpose 2 by 3. And here, okay, the same here. That's the inverse of the matrix. Okay, let's calculate it. C 2 minus 1. So you can see this is not a square matrix, so it's impossible to calculate the normal inverse of this matrix. That means that this is not inverse, not the inverse of the matrix. Okay, it is not. So what is it? As you can see, if you compare, is element by element. If you compare element by element, is the inverse, the multiplicative inverse for each element. Okay, that means that it goes element by element, 2 to minus 1, 1 to minus 1, 4 to minus 1, and so on. As you can see, 1 half, 1, 1/4, 1/5, 1/3, and 1/7. Okay, 1/7. Sorry. Okay, that it is. So what is the inverse? Okay, the same for this one. Oh, it is not possible to calculate this one. Okay, here. Okay, in this case, the real inverse is calculated using the function inv. Okay, as you can see, there is a logic here. If the transpose is T, the determinant is that. So how to expect to use 2 minus 1 for inverse? Okay. So for this, you have to use, if you want to use the function inv, you should use the library matlib. Okay. However, I'm going to use the one that is in the base function is R, solve, and then as you remember, D was a singular matrix. As you can see, it's impossible. There is no inverse, an inverse matrix for a singular matrix. However, let's change the order. A times C. A times C. What was A times C? Of course, is a square matrix. The determinant of this, you see, as you can see here, it was 326, so it's possible, as you can see it here. Okay, and here, as you can see, this should be What could be the result of all this? Okay, if this one is a matrix, and here we're calculating the inverse, what is the result of a matrix times its inverse? The answer is the identity matrix, of course. In this case, it's going to be identity matrix 2. Identity matrix 2, okay? And let's see. And there it is. This is around 0, 0, this one. And this one is around 1. So, it's okay. These are matrix. And, well, these are the operation you can use for a matrix. With matrices or a single matrix, okay? Thumbs up if you like it.